So I can do the equations of motion in any order, but I've chosen this one to do as my second equation of motion. And my starting point is defining what acceleration is. So acceleration is the final speed take away the initial speed over t. So it's the change in speed divided by time, or it's telling us the rate at which the speed is changing per unit time. The speed is displacement over time. So we've got a couple of defined terms there. And to help me, I can actually state that v minus u, so change in speed, is equal to the acceleration multiplied by time. I'm then going to go back to graphing this, and again, a velocity time graph where velocity is a function of time. And I'm going to have the same setup where it starts at a non-zero velocity, gets faster. And this would work if I had it getting slower. It doesn't actually matter, but I think for ease of understanding, it's better if I do it this way. So starting speed, final speed. Now, we're looking at a number of different ways of solving this. And previously, we've seen in the first video, we saw that the displacement is the average speed and multiplied by the time. This one, what other methods have we got for finding this displacement? Well, it's still the area under, but instead of using the Parisian rule, which averages v and u, I can find what this displacement is. So the displacement due to this area, and that is as if the accelerating object stayed at its initial speed. So that's the displacement traveled if it was to stay at its initial speed. This is the additional displacement due to the acceleration. So I can write S equals, and you can see that this is just ut. So this side length is u, this side length is t, and it's a rectangle, so it's ut plus, now this is a triangle, so it's a half, but notice that this length is going to be v minus u. So it's a half of v minus u. Half because it's a triangle, v minus u is that side length multiplied by this side length, which is t. So S equals ut plus a half v minus u times t. Doesn't quite sound familiar yet, but then if you go back to my initial statement about what acceleration is, I can actually replace v minus u with at. So you end up with S equals ut plus a half at times t, and that ends up with a much more familiar S equals ut plus a half at squared.